So today's lecture we will be discussing about the basic logical operations and how we can manipulate data using these logical operations. So today's lecture, the points that I will be discussing is, first I would introduce you to the logical operations such as AND, OR, XOR. Then we will see how to do bitwise manipulation. If you want to change a particular bit, we'll understand a concept called as masking. And after that we will see a bytewise manipulation. So say you have a string of data, and how if you want to change the entire data together, we'll look at inversion as well. Then we will look at two special situations, which are data shifting and data rotation. Okay, so from basic digital operations we know that there are a few logical operations. I'll just spend the next 2 minutes quickly discussing these operations. An AND operation, if I use a 1-bit operation with two inputs A and B, and this is the output O, then if A is 1, B is 0, then my output is 0. If A is 1, B is 1, output is 1. If A is 0, B is 1, output is 0. If A is 0, B is 0, then my output is 0. And again, this is 1 and 0s are bits, as we know. So in effect, only when both A and B are 1 that my output is 1. This is the AND function. The OR function is a little opposite in nature. If A is 1, I'll just write this here. Let's call this AND. I'm going to call this OR. So looking at OR, if A is 1, B is 0, the output is 1. If A is 1, B is 1, output is 1. If A is 0, B is 1, output is 1. If A is 0, B is 0, output is 0. So in effect, if any one of these inputs is 1, then the output is 1. That is the OR. And in XOR, if A is 1, B is 0, the output is 1. If A is 1, B is 1, the output is 0. If A is 0, B is 1, the output is 1. If A is 0, B is 0, the output is 0. So in effect, only when, please understand, only when one of these inputs is 1, then my output is 1. This is for XOR. Another way of looking at this is that, in effect, if both of them are same, then my output is 0. If they are different, then my output is 1. And NOT is basically just inverting. So it's a single gate that if A is 1, output is 0. If A is 0, output is 1. So I hope that this is clear. Again, these are our logical operations. For AND, if either one of these inputs is 0, the output is 0. Both of them need to be 1 for output to be 1. For OR, if any one of my inputs is 1, then my output is 1. And if only when both my inputs are 0, that my output is 0. For XOR, only when one of my inputs is 1, that's when my output is 1. Or if both of them are same, then the output is 0. Well, this is important for us to understand, because now we'll understand how do we manipulate bitwise with a concept called as masking. Suppose if I have a number A, which is 8 bits or 1 byte. So let's name them as B7. This B stands for bit number. B7, B6, B5, B4, B3, B2, B1 and B0. This is 8 bits, and let's take an initial value for A, which is 1 0 1 1 0 1 1 0. Again, this is just a initial value just for explanation. Now suppose I would like to manipulate only B4 and I want to make sure that my other bits, that is B7, B6, B5, B3, B2, B1, B0 are not touched, they remain the same, and I would like to change B4 from 1 to 0. Question is, how do I do that? Well, I would make a mask. I would make a mask such that it's 1, 1, 1, 0, 1, 1, 1, 1. I would make a mask M just for an example, and what I would do in effect is I would take A and use the logical function AND with this. So I would logically AND, use the AND operation between A and M, and what do I get? 0 ANDed with 0 gives me 0, 1 ANDed with 1 gives me 1, 1, 0, 0, 1, 0, 1. So in effect what just happened, that my other 7 bits which I wanted that they remain the same, they stayed the same, but this bit that was B4 that I wanted to change actually changed. So suppose if I want to change it from a 1 to 0 or 0 to 1, I would use a mask and then use the AND operation. That's it. Let's look at a situation where I would like to manipulate B3 and change it to a 1. Well, then I cannot use the AND function. So let's look at that situation. Now if I want to change B3 from 0 to 1, in effect what I would do is, there are multiple ways of doing it, but I'll show you the easiest way. I would change my mask, and instead of doing an AND operation, I can do an OR operation such that I will OR everything with all zeros. All zeros except this bit of my mask will be 1. So in effect what do I get? 1, 0, 1, 1, 1, 1, 1, 0. So what did I end up changing? B3, whereas all my other bits remain the same. So I changed my mask M, but now I performed an OR operation and I was able to manipulate a single bit in a byte. Okay. Now what if I want to manipulate the entire byte? For example, let's write the value again. We have the byte A, B7, B6, B5, B4, B3, B2, B1, B0, and let's give it a value 1, 1, 0, 1, 1, 0, 1, 1. Now if I want to invert, all the bytes, all the bits in the byte, either I can use that previous method that I showed where I would need 8 different steps or 8 different masks. An easier way to do this would be if I take a mask which is M, such as 1, 1, 1, 1, 1, 1, 1. Can you guess what operation I can use? I can use the XOR operation, and let's see what I get. 1 XORed with 1 gives me 0. Remember when I said both the bits are same, my output is 0. 1 XORed with 1 gives me 0. Now these two bits are different. So 0 XORed with 1 gives me 1. 1 XORed with 1 gives me 0. 0, 1, 0, 0. So in effect, these two are opposites or inverts of each other. So again, I can do bytewise manipulation. Now a question to your mind that would come is, what if my mask was all zeros? What would happen? Then my output would be as it is. 1 XORed with 0 gives me 1, 1 XORed with 0 gives me 1, 0 XORed with 0 gives me 1, 1. So if I want, in effect, I did nothing but just for you to understand that if I want to invert my byte or any length, if I want to invert it, I just XOR with a strings of all ones, and that should be fine to invert my data. Now why would we do this is because if in real time during programming, if you would like to invert your data or manipulate your data, you would use these logical operations. Another very common operation that we use in electronics or in microcontroller programming or any FPGA programming as well is shifting. The symbol we typically use, this is for a right shift, this is for left shift. So knowing right shift and left shift, how do we use it? Again, let's take variable A, which is 4 bits, B3, B2, B1, B0, and let's take a value, for example 1, 0, 1, 1. Now if I would perform a right shift operation on this, in effect what I would get is this shifts 1 bit, so this would be 1, B2 would be 1 now, B1 will become B2, which is this, B0 will become B1, which is 1. Now this 1 typically falls off, and well, you can say dies, but falls off, and in place of that B3 gets a new value which is 0. Now this would be right shift. If I would do a left shift on this, then in effect what I would get is this would shift 1, this would shift 1, 0, this guy would fall off, again this is for left shift, and in place I would get a new 0. I hope that was clear. Now typically if I would use right shift, I would write it as A right shifted by 1. So this is the source byte or source data, and this is the amount with which I would like to shift this. So if I would write A right shifted by 2, then if I have 1, 0, 1, 1, then if I right shift this by 2, effectively these two guys fall off, these two guys come in their place, 1, 0, and in effect I have 2 zeros here. Again, this is right shift, the same logic can be applied to a left shift. Now that said, how do we understand the concept of rotation? Now a rotation is a little different from shifting. Let me quickly explain that. If I have A again, B3, B2, B1, B0, 1, 0, 1, 0, and if I do a right rotation means that I first shift 1 bit to the right, which would give me 1, 0, 1, and this guy does not fall off but comes in place of B3 as this. Now this is a right rotation. So how do we end up doing that? I would accomplish this by a two-step process, which is actually 2 small shifts that I would do. First, I need to accomplish a right rotation. So first I would right shift my A with 1, just a shift, it's not a rotation. The rotation is split into 2 steps, which is the first step is shift right A, which effectively would give me 0 1 0 1, because this guy technically fell off and in place of him another 0 came by. And then what I would do is, to reclaim this 0, I would take the original A again and left shift it by 3. So in effect I would get 0 0 0 0. This is A left shifted by 3. This is A right shifted by 1. I would take both of them and I would OR them, which would give me 0 1 0 1. Let's look at another example. Suppose I would like to do a left rotation on A. Suppose I would like to do a left rotation on A. Let's take the value again, 1 0 1 0, and if I would like to do a left rotation, so my expected answer is 0 1 0 1, and this guy that was supposed to fall off comes here. So it's a left rotation. So again I would do that in 2 shifts. First I would take A and I would left shift it by 1. So this would be A left shifted by 1, which would give me, it would give me 0 1 0 0, because this guy came here, this guy came here, this guy came here, and this guy fell off, and in place of him a 0 would appear here, which would be here. Now second step would be, I again take A and I right shift it by 3. So I would do A right shifted by 3 so that I can reclaim this lost guy. And what do I get it when I right shift this by 3? I get this shifted right up till here, and all the others would be 0. So I would get 0 0 0 1, and I would OR these two to get 0 1 0 1, which is effectively A, which is left rotated here. So again, this was rotation, and you can apply this concept to any size, just you need to understand how much I need to rotate this wire and what would be these shift numbers, whether it's a left shift or a right shift. That logic, I hope you guys can apply that. So in the next lecture we will take some programming examples for these logical concepts and try and do a lab on it and actually see how it works on hardware.